In this collection of videos, we are going to introduce functions. Now I want to give a little motivation for what computer functions are. And for this, I want to return back to Grace Hopper, that queen of computer code. And shown over here on the right is a book I actually have for my kids, which is super awesome at explaining the many accomplishments that Grace Hopper contributed to in computer science. And the quotes from the book that I like to explain why we use computer functions is that one day Grace was looking back through her work and found some code that she had written before. And as she was looking through her program, she found that she was using the same code over and over and over again. And she thought to herself, what a colossal waste of time. Why not make the computer do the work of the copying that code over and over again? After all, that's a great fit for computers. They're good at doing mundane things very quickly. So Grace Hopper, of course, figured out a way to store that piece of her program inside the machine, and then when she needed to use that code, instead of her writing it again, all she had to do was tell the computer where to go find that code, so the computer would go look it up and copy the code for her. And that's precisely the idea behind functions in computer programming. So what we'll see as we work on functions, because functions are a really big deal in computer programming, is that there are two different reasons that we might use a function within a computer program. One reason that we might use a function is to group a set of instructions that we wish to use repeatedly, as in the case of Grace Hopper's example. But there's another reason that we might use functions, and this is sort of the looking forward reason that we might use functions as we get deeper and deeper into computer science, and that is to take a task that might be long or difficult and complicated, and we might want to encase it so that we go put it somewhere else so that anyone else reading our computer code doesn't have to read that complicated, difficult expression, but can just see, what is the purpose of that? What would that do? Let me just call that function. I don't actually need to know how it's accomplished. I just need to accomplish it. And that can help us not have to go through long, long lines of complicated code. It just lets us be a better user of other people's programming. With writing functions in Python in particular, we're going to have two different ways of interacting with functions. We are going to have the process of defining and creating a function. That's like when Grace Hopper was writing the code over and over and over again. She did need to write the code one time. And that's what's going to happen when we're defining our function. We're going to write the code one time. But then when we go to use that code repeatedly, what we are going to need to do is call the function, what Grace described as telling the computer where to go find where we made the definition of the function. So we're going to have those two aspects of functions, the process of defining the function, writing it the first time, and then using or calling the function, which we may do several times throughout the course of our program. I'd like to go over the syntax for defining a function and calling a function, those two uses that we described on the previous page. The first thing we'll need to do is define the function, and the syntax for that in Python is as follows. We're going to use the Python reserve word def because we're making a definition and we're defining our function. Then just as we would name a variable, we need to name our function. So the function name comes after the word def. And then what is mandatory for making a function definition is this open parenthesis and this ending parenthesis along with a colon. Those parts, what's written in black on this line right here, and of course the part that's written in blue, all of those are the mandatory parts of our function syntax. Something we'll discuss a little bit more later is that sometimes when we write a function, not all the time, there are pieces of information that we might need from the rest of the program in order for the function to do its job. And those things, when we define a function, are called parameters. And we can have as many parameters as we would like, And if we have more than one piece of information that needs to be passed to the function, a first parameter, a second parameter, and so on, as many as we'd like, we separate those parameters between the parentheses via commas. Remember, those parameters, they're written in green, they're totally optional, but we always need this open parenthesis, the closed parenthesis, and the colon at the end. When we call a function, we are not going to need the reserve word def, because we're not making a definition at this point. We're calling the function. We're not going to need the colon, because what the colon is actually going to do is start that indentation process for when we're defining the body of a function, much as we would the body of a branching statement or a looping mechanism. So since we're not doing that, we don't need the colons here when we call the function. We will call it by its name, and then within the parentheses, we will pass to the function whatever it needs. And at the point in the code when we call a function and we pass the function what it requires, the values that we put in here to match up with the parameters are called arguments. So if I have n parameters here when I define the function, in order to call the function, I will need n arguments. And those arguments are ordered and they match up one-to-one in the order that they're written with their parameter numbers. It sounds a little complicated, but gets much easier with a small example. We'll go through this example again later on in our videos, but just to give you an idea of what those things look like when we're coding, I've created a small function here. I've defined the function on line 2 with the reserve word def, and I've named my function Pig Latin. In case you're unfamiliar with Pig Latin, what that does is it peels off the starting sound of a word, the consonants at the beginning of a word, and then it tacks them onto the end, and then adds the bit A after it. So I've included the output of some examples here. So that's precisely what my Pig Latin function does. My Pig Latin function does require one parameter. It requires a word. To that word, we are going to extract from it all of the word starting in the first position and onward. We're going to neglect that initial sound, the value of the word at position 0, and instead of that character being at the start of the word, let's take all of the word except that starting character and begin with that. Let's add to it the starting sound, now at the end of the word, and then let's end the word with the AY part of the Pig Latin process. And all of that together will create a new word. That new word is the Pig Latin version of the word that was passed in as a parameter. We will then print the Pig Latin version of the word, which is new word, and that's the end of the definition of the function. If we then wish to use the function later on in our code, we need to call the function. I call the function by its name, Pig Latin. I use my open and close parentheses, and inside the parentheses I need to put my argument, the thing that will take the place of the parameter word when I call the function. So once I type in line 7, I call the Pig Latin function with the argument pig. What then happens to the flow of control of my program is we come up here to the definition of Pig Latin, and we have passed it the word pig. We will create new word, which starts at position 1 and goes to the end of the word. That's the IG part, ig. We add to it what was in the word at position 0, that's the P, and we add to it the A. Our function then prints the new word, which is how we're getting this output here, and that's the end of the function call on line 7. Notice the power of functions. I can call the function again without having to rewrite this code. In line 8, I call the function Pig Latin with a different word. My flow of control goes from line 8 to lines 2, 3, and 4 again, And once that body of the function is executed, my flow of control would return to line 9, which is not pictured here.